Let us look at proposition number 29 of book 7 of Euclid's Elements. The proposition says any prime number is relatively prime to any number which it does not measure. What does that mean? You have a number A which is a prime number and there is another number which it doesn't measure. So A doesn't measure B. So in that case, they are relatively prime. Okay, let's see how we can prove this. We are given that A is a prime number. B is a number that A does not measure. So A does not measure B. What this basically means is that B is not a multiple of A. Assuming that A and B. So again, we look at contrary to what we want to prove in proof by contradiction. So assuming that A and B are not relatively prime, then some number must measure both of them if they are not relatively prime. So let's say that number is C. C measures A and B. C measures B. A does not measure B. Therefore, C is not equal to A. So, C measures A and B. But A is prime and A is not equal to C. Because remember, the definition of a prime number is what? That it is measurable by the unit and the number itself only. So A is not equal to C. That means no number measures A and B. So our assumption was what? Assuming that A and B are not relatively prime. So we have reached a contradiction. So that's why we can say A and B are relatively prime. It's a little bit tricky. So you might have to go through this a few times to understand what is happening. That is proposition number 29 of book 7 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it. And if you feel somebody else can also benefit from it, please do share. That's it for now.